Okay, 8th graders. Chapter 6 is about the slope of lines. The change in the y-coordinate over the change in the x-coordinate. It's called the rate of change. Oops, wrong notes. There we go. So, if you understand the rate of change, you understand that you're finding the slope, how fast it's changing. If it is a gradual slope, it's going to be a lower number. If it's a steep slope, it's a higher number. If it's going up to the right, it's a positive slope. If it's going down to the right, it's a negative slope. All right?
What about down to the left?
Down to the left is also up to the right. Isn't it? Oh, yeah, look.
I get it.
See, this is down to the left or up to the right. Okay.
Oh, that makes more sense.
And you generally read slope as you're moving to the right. Okay? Just like you're reading a book. Now, the slope, you can find the slope in a number of ways. You can take the x and y values. You subtract the x values. Subtract the y values on the top line. Subtract the x values on the bottom line to find the slope. Because the slope is the change in y over the change in x. Okay? It's also called the rise over the run. How far up it goes for every space to the right. Here's something you need to know. A horizontal line, a line that goes straight across, has a 0 slope. Because how much does it change going up? How much does the rise change? 0, doesn't it? If it's a flat line, if it's a horizontal line, then the rise, how far up the line is going, is 0.
Doesn't matter.
Right?
If you're trying to measure going across and going up, doesn't matter.
No. It's changing 0. Look at this line from A to B. That's the horizontal section of the line. How much did the y-coordinate change?
0.
It's 0. It stayed at 10.
Okay.
Now, a slope that is straight up and down is called an undefined slope. So if the line is a vertical line, you would say that the slope is undefined.
So when you're trying to find if it's a function, you graph this like the
right. Yep. Yeah, if it's not a function, then it's an undefined slope. Yep. So there's another way to find slope, and that's by counting from one point to the other. Let's say that you're given a graph that says find the slope. You can find a point along the line. It's usually easiest to find a whole number point. Like this one, point A to point B, assuming that these are, the interval is 1. You can count up and then over, or the rise and then the run. It goes up 1, 2, 3, and then over 1, 2, 3. So the slope is 3 over 3, which we would reduce to 1 over 1, the slope of 1. Now, you could also count down and over, and that would be a negative number, -3 over -3. It still gives you the same slope, doesn't it? 1, -3 over -3. Okay? So, again, you find 2 points that intersect a corner, whole number of points, count up or down, and then to the right. Count up and to the right if you're going to go that direction. Or if you're coming down, you need to count down and then to the left. Okay? You don't want to count down and to the right. You have to go either down to the left or up and then right. Okay? Now, another way to find the slope is to, if you're given 2 points on the line, to find the difference in the y-coordinates and then write that over the difference in the x coordinates. So look at this. Look at these 2 points. Look here. Negative 3 over 1. I'm sorry, negative 3, negative 1 is point A, and 0, 2 is at point B. Okay? So to find the slope of these 2 points, you take the y coordinates and subtract them. Now this is a key in subtracting these. If you do A minus B, if you do the y coordinates, the y coordinate of A minus the y coordinate of B, then you have to also go back and do subtract the x coordinates in the same order. Okay? You have to do you have to subtract them in the same order. If you do negative 1 minus 2, you have to also do negative 3 minus 0. You can't do 0 minus negative 3. That would be doing the x coordinates in a different order. It's going to give you a different answer.
You have to find the first set. I don't know.
Okay? So negative 1 minus 2 is negative 3. And then go back to A, start with A, and do negative 3 minus 0 is negative 3, which gives you the same slope, slope of 1. Okay? Now, let's see, that's for tomorrow's lesson. Let's go to your lesson today. Look at number 1. You're given that table on page 312. You've got the x values on this side. Time is the independent variable, and the temperature is the dependent variable. So, if we think of these as 2 points on the line, these are the y coordinates, and we would want to subtract those. y2, that's the second coordinate of y, is written as y2, minus y1. So, negative 2 minus 7.
Why is y2 the first number?
It's just how you'll see it written in the book.
I mean, why
wouldn't it be 7 minus?
It's, yeah.
You said negative 2 minus 7.
Oh, I'm sorry. Negative 7 minus negative 2. Okay? If we do y2 minus y1, then it is 7 minus negative 2.
So isn't that technically 9?
That is technically 9.
Yep.
It is 9.
Right. So the change in the y is 9, and the change in the x is, we have to do 4 minus 1, because we do the second x coordinate minus the first one. Okay?
Which is
So that is
3 over 1. 3 over 1.
3 over 1. So the rate of change, or the slope, is 3, positive 3. Okay? Or it changes 3 degrees per 1 hour. For every 1 hour. Okay? Let's look at number 3. That one's given as a chart. Or not as a chart, I mean as a graph. So what do we need to do with the graph? How do we find the slope using a graph?
You turn the graph into the points.
Yep, find the points on the graph. Now, so, well, one of the points is right at 15, isn't it?
5 and 15.
5 and 15? Isn't it right on the y-axis?
Also, it's also
So
on
it's
150. It's
0.
150 and then up 5.
One of the points is 0, 15, isn't it?
And your next one is 150 or 550. No, 155.
And then 150.
155. That's
It's
What's that?
150 and then 5.
150.
on the bottom and 5.
What's the
upwards.
x coordinate?
150.
No.
150, comma, 5.
Yeah. It goes up 5 and it's over 150.
Okay. Okay. So now we can subtract the y coordinates. So if you subtract these going that way, 15 minus 5, then subtract the x coordinates over 0 minus 150. It's the change in y over the change in x.
What if like there is
10 over negative 150, or what could that be reduced to?
150 divided by 10 over x.
that's 150.
It's 1 over
Yep.
negative 15.
So it's negative 1 over 15. Negative 115.
What if like the line doesn't cross any definite point, like at home?
It has
Like on the number that shows how it always crosses through some like actual
Yep.
whole number.
Yep.
Does it ever not do that? Or does it cross through whole number like
If it doesn't, then you can use fractions, or you can use decimals. Okay. You might have to subtract 15.5 minus 5.25. All right. What about number 10? Number 10, you're given 2 points.
Can we just do the same thing, put one over the other and subtract it?
So, what do you mean?
Like put like 3 over 2 over 5 over 6 and then subtract 2 from 6 and 3 from 5.
And
Like the thing you just did.
like that, and then which ones do you do? Which one would you subtract?
2 minus 6 and 3 minus 5.
Yep. So 2 minus 6, and then 3 minus 5. What if one of the points was negative?
You have to put it in parentheses.
Put it in parentheses. You still have to subtract the negative. So you
like
might have,
what if like 6 was negative? What if you just did 2 minus negative 6? Like if the 6 is a negative number, why would you just do 2 minus negative 6?
2 minus negative. Yeah, if this was negative, then it'd be 2 minus negative 6. You're right.
So then why would
Then it'd be 2 plus 6, which is 8.
So then why would you put it in parentheses? You just said if it's
What would you put
negative.
in parentheses?
You just said if it was negative, you put it in parentheses.
Well, sometimes you'll see the minus sign separated by parentheses. Okay? Just because if you're substituting a negative number in, you might put it in parentheses. Okay? So again, you're just subtracting the y's, finding the difference in the y coordinates over the difference in the x coordinates for this lesson.
Can we take another day
Okay.
on this?